Hello there, welcome to this video on solving trigonometric equations. We're going to look at linear and quadratic structures of trigonometric equations. You're going to need to have knowledge of the unit circle. So hopefully you have the unit circle angles and coordinates memorized. Hopefully you can utilize a strategy such as the left hand trick. And if not, if you're still struggling with those ideas, maybe you just have a copy of the unit circle by your side as you progress through this lesson. And again, try to wing yourself of that. You're going to need to have this stuff memorized, okay? All right, so let's go ahead and start off by looking at functions cosine and sine. And what we really want to look at is what's their domain and their range. Like, what can I plug into a function and what can I expect to get out? Domain is all real values for our first function, which is cosine of x. So I can plug in anything from negative infinity all the way to positive infinity. Now, what can I expect to get out? Okay, what's my range for the cosine function? And you'll notice here I have a visual of it, and that is -1 to +1. So the range has to be between -1, +1, inclusive. And that makes sense if you think about the unit circle, right? Cosine being the x values. It's +1 at angle 0, and it's -1 at pi, okay? And it always just oscillates between those. Similarly, when we look at the sine function, again, the domain is all real values. I can plug in any angle from negative infinity to positive infinity, and the range, again, is 1 and -1. Sorry, so -1 to 1. So again, we can expect to get these values out. If we get anything out outside of that, anything lower than -1, anything bigger than 1, we end up throwing those answers away. Okay, so let's go ahead and look at some problem-solving strategies, and here's some general steps to solve trigonometric equations. Now, it depends upon the structure. If you have a linear structure, what you want to do is combine like terms, isolate the trig function. Whoa, the lights just went out. They're back on. And then you want to find the angle measure that corresponds to that function value. That's where you'll use your unit circle. If we have a quadratic structure, what we'll want to do is write the equation in standard form and then use a strategy. Now, that may be taking the square root of both sides, maybe factoring using our knowledge of trinomials or binomials. And then once we have our trigonometric function isolated, you'll want to go ahead and, again, find that angle. Okay, so let's go ahead and look at an example. And here, the example says, solve each equation over the interval 0 to 2 pi. Okay, so they've given us our domain, what we're looking at. And the first thing that we're going to go ahead and note is that this is a linear structure. So how do I know, again, that this is a linear structure? Well, I don't see any trigonometric equations or trigonometric functions squared. Okay, so again, what we'll want to do in order to go ahead and solve is combine like terms. So I'm going to add my signs together. Okay, and this will give me 2 sine x plus root 2 is equal to 0. So now I'll subtract root 2 on both sides. And I get 2 sine of x is equal to negative square root of 2. Okay, I want to isolate my sine function, so I'm going to divide both sides by 2. And we get sine of x is equal to negative root 2 over 2. Okay, so essentially what they're saying is, where is sine of x equal to negative root 2 over 2? Now, here's where you have to go ahead and you're going to use the unit circle. Okay, and use the unit circle. And if you're really good, you can go ahead and if you have this memorized, you can know what these angles are right off the bat. Okay, and that would be 5 pi fourths, comma 7 pi fourths. And if you're just like, whoa, how the heck did he know that? I'm going to go ahead and I'm going to talk you through kind of that metacognition, just my thought process. Okay, so what I see is I see sine of x. So I have to ask myself, is this x or is this y? And of course, sine is the y value. Okay, then I want to know what type of angle are we working with? So here's where I use something like the left-hand trick, okay? And again, if you're not familiar with the left-hand trick, go ahead and maybe watch a video on that. So I put down, you know, my pi-4 finger, okay, and that confirms, right, my y value is root 2 over 2. So I know that this is a pi-4 angle, okay? Then what I want to go ahead and do is I notice that this is negative. It's negative root 2 over 2. So I say, okay, like what quadrant is sign negative? Okay, and what quadrant? And if you think about the acronym all students take calculus, this tells you where everything is positive. So you'll note that sine is positive in quadrant 1 and 2. So it's going to be quadrant 3 and quadrant 4. All right, so that's how we get 5 pi over 4 and 7 pi over 4. And that's it. Okay, here is a practice problem. Please pause the video. I want you to go ahead and try this one. Hopefully you have tried this. Here is the solution, and you should have gotten cosine of x equals 1/2, which is the angles pi thirds and 5 pi thirds, right? It's positive in quadrant 1 and in quadrant 4. Okay, so that's it for the linear structure. Now we're going to go ahead and we are going to look at quadratic structure. Okay, again, I know that this is a quadratic structure because I have my square right here. So what I'm going to want to go ahead and do is first note that it is in standard form, right? And then what we're going to go ahead and do is kind of solve it. So I'm going to add 1 to both sides. Okay, giving us 3 tan squared of x is equal to positive 1. Divide by 3. We get tan squared of x is equal to 1/3. Okay, and then at this point, note I can go ahead and I can rewrite tan squared, and this is just something weird that trigonometric functions do. So when they have a function squared, they just move the power inside. Okay, so I really have tan of x squared is equal to 1/3, and if I go ahead and take the square root of both sides, what we get is tangent of x is equal to plus or minus square root of 1 over the square root of 3, which is equal to plus or minus 1 over root 3. Now, if you're looking at this and you're like, I have no idea where tangent of x is equal to 1 over root 3, that's fine. Then that's kind of understandable at this point. We haven't looked at these functions yet as far as graphing them. But what you can do is you can use your knowledge of special right triangles. So if I have an angle here, okay, tangent is opposite over adjacent, and I want to know, okay, what type of angle is this? Okay, and using your knowledge of special right triangles, you know that the smallest side corresponds to the smallest angle. So since this is 1, right, that's going to be 30 degrees, okay, and this is a 30-degree angle. All right, so what we want to go ahead and do is say, okay, all right, where is tangent of x, a 30-degree angle or a pi 6 angle? And we want positive and negative. So that's going to be in quadrant 1, it's going to be positive. In quadrant 2, tangent of x is going to be negative. Quadrant 3, tangent is positive. And in quadrant 4, tangent is negative. So that's every single quadrant. I'm going to include the pi 6 angle. So x is equal to pi 6. Okay, in quadrant 2, that's 5 pi 6, right? One back from 1 pi. In quadrant 3, it will be 7 pi over 6. That's one quadrant forward, and one backwards from 2 pi gives us 11 pi over 6. Okay, and there is your answers. All right. Here is a practice problem. Please go ahead and pause the video. I want you to try this one, and if you get stuck, start the video. I will show you kind of a hint. All right, so if you did get stuck, what you should have had is sine of x equals plus or minus the square root of 3/4. Now, that can be tricky sometimes for us to know that we can split up the numerator and the denominator, and then also that I can go ahead and take the square root of 4, right, which gives us 2. So this is a root 3/2 angle. Okay, go ahead, pause the video, and finish this one up. All right, so hopefully you have finished it. Here is the solution, okay? And those are your answers. So plus and minus every single quadrant, and this is a pi-third angle. All right, so let's go ahead and look at another example. And note that in this example, again, this is a quadratic structure. Okay, but note that this example, it is not in standard form. So step 1, what I'm going to go ahead and do is I'm going to put it in standard form. So I will subtract 2 cotan x on each side. Okay, and I get cotangent of x times cosine squared of x minus 2 cotan x is equal to 0. Okay, and you have to kind of stop here at this one and look and see, like, what do I see? And I hope what sticks out to you is that cotangent of x is in each term. And generally when this happens, what you're going to want to do is you're going to want to factor that out. So I'm going to factor out a cotangent of x, and I get cosine squared of x minus 2 is equal to 0. Okay, and now what I can do is I can go ahead and I can utilize the zero product property, right? Which tells me that cotangent of x is equal to 0, okay, or cosine squared of x minus 2 is equal to 0, okay? So we'll go ahead and solve these respectfully. Okay, and what I'm going to do, cotangent of x, I don't really know anything about that in the unit circle, so I'm going to rewrite this as sine of x, sorry, not sine of x, come on, Schwarberg. This quarantine has me going crazy. Cosine of x over sine of x is equal to 0, okay? And really, what this is, okay, I want to know where is cosine of x equal to 0. Okay, so where is cosine of x equal to 0? And that is going to occur here. Sorry, not there. What am I doing? It's going to occur here at pi halves and at 3 pi halves. And kind of like just another way of thinking about this is 0. It could be 0 over 1, or it could be cosine of x over sine of x is equal to 0 over -1. Generally, when something's equal to 0, you're just going to set the numerator equal to 0, right? And so what we get is that x is equal to pi halves and 3 pi halves. Okay, so those are two angles. Let's go ahead and check out cosine squared minus 2. So I'm going to go ahead and solve this, and I'll add 2 to both sides. There go the lights again. Okay, so cosine squared of x is equal to 2, and I'll take the square root of each side, meaning that cosine of x is equal to plus or minus square root of 2. Okay, and at this point, what I hope you notice is that square root of 2, that this is approximately 1.4. Okay, and you need to remember, right, that the range for cosine and sine for that matter, right, is -1 to 1. So what do I do with this answer? Well, we kind of throw it out, right? It is invalid. So extraneous, if you will, right? So here are our solutions, okay? All right, here is a practice problem. Please pause this one, go ahead and give it a go. All right, hopefully you have paused it. Here is the solution. Okay, and you should have gotten 0 and pi, right? Sine of x equals 2. Again, 2 is outside of the range, right? So we throw that one away. All right, here's another practice problem. Please pause the video and try this one. All right, hopefully you have paused it. Here is the solution. And on this one, right, we get cosine of x equals 0. So that can occur at pi over 2 or 3 pi over 2. And then 2 cosine of x minus root 3, well, that gives you root 3 over 2, and that occurs at pi 6, 11 pi 6. So what's our answer? Well, it's going to be everything, right? It's going to be all of those answers. All right. Okay. Here is the last example. And what we have is, again, a quadratic structure. And I'm going to go ahead and I'm going to put it in standard form, right? So step 1, make sure that it is in standard form. So I will subtract 1 on each side, giving us 2 sine squared of x minus sine of x minus 1 is equal to 0. Okay, and what we need to think about is you need to think about, okay, what if it wasn't sine, right? How could I factor 2x squared minus, that's a square, I promise, 2x squared minus x minus 1, okay? And the answer to that, right, would be 2x plus 1, x minus 1. Okay, so I can go ahead and I can factor trigonometric equations just the same as I would another polynomial equation. So this is going to give us 2 sine of x plus 1 times sine of x minus 1 equals 0. And then, okay, I have here 2 different situations. So 2 sine of x plus 1 equals 0. And sine of x minus 1 equals 0. Okay, so I can go ahead and now solve. So I'll focus on the first one, minus 1, minus 1. So 2 sine of x is equal to negative 1. Divide both sides by 2. Okay, and we get sine of x is equal to negative 1/2. All right. Okay, and so where does sine of x equal negative 1/2? Okay, so first of all, I know that the angle, right, that we're working with is going to be pi 6, because that's where our y value is 1/2, and I want sine to be negative. So I'm thinking about this, that's going to be in quadrant 3 and in quadrant 4. Okay, so this is going to be 7 pi over 6 and 11 pi over 6. Okay, and if I'm going to solve the second part, I'll add 1. So sine of x is equal to 1. Okay, where is sine of x equal to 1? And for the quadrantals, I just drawing a picture sometimes help, right? My y value is 1 up there. Okay, so x is equal to pi halves. There you have it. That's it. All right, here is the last practice problem. I know this one's a long one. Okay, go ahead, please solve this one. All right, so hopefully you have tried this. Here is the solution. You should have gotten angle 0, pi thirds, and 5 pi thirds. Now, a common error on this one is going to be here for cosine of x equals 1. You guys might have said 2 pi here. Now, why is it 0 and not 2 pi? Well, it goes back to the interval that you're solving on. So it's 0 included, 2 pi excluded, right? That's what the parentheses and the brackets mean, notationally wise. Okay, so you got to pay attention to that. Whenever you're going to include, is it 0 or 2 pi? They're coterminal. You have to pick the one that's included. All right, so that does it for this lesson. Sorry, it's kind of a long one. This is a 2-day lesson, so hopefully you spent some time doing this one. All right, I'll catch you next time. Take it easy.